Hello everyone, Reginald Scott here, and welcome to my video presentation on the basics of bottom brackets, what the problems are, and how we can solve them. So today I've got two frames here in the picture. One of them is a threaded bottom bracket and the other one is a press fit bottom bracket, just as representation purposes. These are both metal frames and I will get into that later. The main reason why I'm using these two frames is because they happen to be the kind of frames that I sell in the shop. And then down here we have an assortment of bottom brackets. This is not all the bottom brackets available on the market, but this is just an assortment of different types of bottom brackets that we'll be going through later. Right, let's get on with it. So what we have here, starting from the middle, this one is what people refer to as BB30. Okay, so you get two of these within BB30. These are just actually bearings. We talked and discussed bearings in a previous video about ceramic bearings, but this is, as I say, just a bearing. So inside here is a ring of metal balls inside a cage, two seals, and two racers, inner and outer race, and that's what makes BB30. BB just means bottom bracket. 30 refers to the diameter of this bottom bracket, which is 30 millimeters, all for a 30 millimeter spindle. So that's pretty simple. They're very common. You'll find those in quite a few bikes on the market. A lot of specialized bikes come with BB30. The specialized Ales Sprint, for example, is a very popular bike that has a BB30 bottom bracket. Another bearing which uses a 30 millimeter spindle is this one. This is a press fit 30. So basically it's the same bearings as a BB30. Oops. As you can see, they're identical, except this one is in a set of cups. Now these cups are just a polymer, they're a plastic. They can be various different types of plastic. They come with little shields on them to protect them from water and things when you're washing your bike and stuff like that. But basically these two bearings are pressed together from either side of the frame. Yeah, basically the same thing as BB30, same diameter. Now if I can demonstrate, this one and this one actually mate together. So this shell here on this titanium frame, this Lightspeed titanium T5, is a PF30 bottom bracket shell, and so this bearing will happily fit inside that shell there. It's just pressed into the shell. So that's PF30. Another PF30 is this one. This is exactly the same bearing, except as you can see, this one is made of plastic and this one is metal. Difference being that instead of being just straight pressed into the frame, you have these fins or rims basically on the edge of the bearing. They're keyed, so they have little cuts out of them which are used for a specific tool, and then this is actually threaded. Okay, so the center of this bearing unscrews and you basically put one in one side, one in the other. The two will touch in the middle. You put a little bit of grease on it here just to protect the threads, and then you'll use two tools and you will tighten the bearing like this into the frame, and it's exactly the same thing. It will go into this frame quite happily here, this PF30, and it is a PF30, but like I say, just a different style, using a different material, and I'll explain what the advantages are of that later, or why that's become necessary to have those. Then probably one of the most popular bearings on the market right now is this one, which is BB86. This is the Shimano standard. This particular bearing by BBB comes with a metal cup. So these two cups are metal and they have a plastic sleeve inside as well, and these are also just pressed into the frame. Same concept as the PF30 basically, but it uses a smaller diameter. This is a 24 millimeter Shimano sizing for this one, and we also have that one in the screw type, so just the same as this one, but we have BB86 threaded type or screw type unit. And then this one is the most common BB86 on the market. This is the Shimano one that comes with most Shimano group sets. It has grease already inside it, which I'll try not to touch because according to the Shimano manual, it warns you about touching this with your bare skin. It says the grease is hazardous, so I'll abide by the Shimano manual. And again, this is just plastic instead of metal, and again I will explain later why some come with metal and some come with plastic. This is just a molded plastic, and the bearings are inside this one. Just pop that back in. That's pretty much all we need to discuss about that. And then finally, the one that's the big talking point, I suppose, at the moment. A lot of people talk about this one, and this is an absolute favorite among many people, is this one, which is a BSA threaded bottom bracket, British Standard threaded. You also get the Italian threaded type. The Italian threads are, the threads are standard. They basically tighten to the right and loosen to the left. These BSA ones, they actually have a reverse thread on one side so that when you're turning your crank it doesn't unscrew. But again, this one just has a plastic cup in the middle, again to protect the inside of the bearing and your spindle from water. And these are threaded into the frame. They're screwed directly into the frame. This frame over here, this Bowman, an aluminium frame, you would just pop that in there with a little bit of grease or a little bit of what do you call it, copper grease or something, copper slip, and you would just proceed to screw that bearing directly into the frame. Let's see if we can focus on that so you can see the threads. There you are. So as you can see, this is the right hand side. You've got how many Newton meters on here to tell you how much to tighten it, and you've got the pitch and the number of threads as well on there, and it's for a 24mm spindle. This is in the internal diameter of the bearing. So, but that is just a very quick overview of some of the main kind of bearings that are on the market. All you pretty much need to know is you have threaded ones, you have press fit ones, and you have ones, let me focus again, sorry. You have threaded ones, you have press fit ones, you have ones that press directly into the frame without a cup, and you have the screw type ones as well. Alright, this one just to show you. This is an adapter bearing. This is actually the same one as this. Okay, so the diameter, the external diameter of this bearing here is the same as this diameter on this edge. This fits into those bikes which use a BB30, and it adapts them to 24mm. So basically this turns a 30mm spindle style bike with a 30mm bearing into a bearing that will work for a 24mm Shimano. But we also sell bearings like this that screw into the Lightspeed frames, the PF30s, which also adapt them to 24mm, but I just don't have one outside the case right now. So, and it's not really necessary, it's just demonstration purposes. Right, so that's all the different bearings that we're going to be discussing today. The next is, as I say, the types of shell. So you get two types of shell pretty much on the market. I suppose three if you want to be pedantic. You get those which are threaded directly into the frame, and you get those which are press fit. I'll show you the press fit one a bit closer. So it is literally just a tube. There's not much technical about it at all. It's just a big old tube. It's got smooth sides to it, and you force, there's contact fit in there. You force the bearing in with a bearing press until it touches the edges of this shell, and then that's pretty much, and it's all that happens, and it's held in there by the friction of the cups pressing against the inside of the frame, but it's also held in there by the type of crank that you use. Obviously when you bolt the crank together on your frame, whether you're using something like a SRAM that uses a single bolt, or whether you're using a Shimano which uses 2 bolts, it just holds everything together pretty much so that that bearing can't fall out of your frame. And then I'll give you another close-up this one of the threaded. So let's focus here. This is quite hard to hold. There we go. There's the threads within that bearing. So that's again a metal tube, and it's been machined with threads in it. You can actually see that the metal tube was a single piece that was then welded into the rest of the frame. So they made the tube probably separately, and then they threaded that tube, and then they welded it into the frame. Or they welded the tube into the frame and then they threaded it. That I do not know, but I'm guessing it's one or the other. And then, as I say, the spindles. So the spindles are, as I say, 24mm generally, or 30mm. There are of course other spindles out there on the market, rarer types that don't conform to those two sizings. We now have a new one from SRAM called Dub, which is, I believe, 29mm rather than 30mm, and that comes with its own collection of bearings that are designed for it, and it will also probably come with adapters as well. Let me just show you a bearing adapter as well, so you understand that. Right, so this is a bearing adapter. As you can see, this one reduces a 30mm spindle down to a 24mm spindle. It basically does the same job as this one here, but this is designed in case, for example, you have a PF30 bottom bracket in your bike and you want to run a Shimano crank, and obviously you can't do that with a 30mm hole there, you need a 24mm hole. So this adapter just goes in there like that, turning a big hole to a slightly smaller hole, and thus allowing you to fit a different kind of bearing, different kind of spindle system. So now we come on to the real nitty gritty, which is why are there so many problems nowadays with bearings and bottom brackets? Back when I started riding, this was the standard bottom bracket pretty much for every bike, because pretty much every bike was an aluminium bike or a steel bike. Those were our choices back then. Carbon frames were rare, and you know, they really weren't affordable for a start. I mean, they were really very, very expensive, twice as much at the time. I remember when I went to buy my first aluminium racing bike, as my aluminium frame, and as I say, they weren't that common. So this was the bearing standard, and a lot of people love the threaded bottom bracket, and the reason why they love it is because it's associated with trouble-free operation. A lot of the creaking, the squeaking, the misalignment, and the issues that we get with bottom brackets are generally blamed on the press fit types. These ones, and these ones here. Okay, so those bearings that press directly into frames, and those that come with cups, whether they be plastic or metal, these are the ones that get blamed with all the issues. And this one, the BB86 adapted one, and the PF30 one with threaded internal cups, they were kind of brought about to solve the problems, or attempt to solve the problems that these ones had. Why do people think that this system is better? Well, as a few engineers, including Lucius Technic, have pointed out, this is no different from a press fit bottom bracket, in the sense that what you have here is a bearing which is pressed into a metal cup, and then that metal cup is threaded into a frame. Now his argument is that this shouldn't be any better than a press fit bottom bracket, because it's the same thing. It's bearings pressed into a metal cup and then screwed into the frame. So why is this better? Well, there's two reasons why this is better, or more reliable than the other systems. The first reason is, and probably the most important reason, is frame material. The kind of bikes that don't have problems and that use these kind of threaded cups or threaded bearings tend to be metal bikes, either aluminium or steel or titanium. The second thing is these bearings are being pressed into solid CNC machined, highly precision metal cups. Unlike these bearings and these bearings, which often get pressed into carbon fiber frames. And when they are pressed into aluminium frames, there are other issues that you have to contend with. Okay. So the reason why this system or a threaded bearing is more reliable for a threaded frame or a threaded bottom bracket shell is because this is more reliable. The aluminium cup that this sits in is precision made. So this bearing doesn't move around, it doesn't twist, and it fits perfectly. So what you have is a straight hole all the way through. You don't have any discrepancy from one side to the other. And if that threaded bottom bracket is made well, if it's just a metal tube that again has been cut with a lathe or a CNC machine so that that tube is precision, and then the threading is done well, then that tube will also have no discrepancy in it from one side to the other. It will be straight, it will be true. Once you put this in, you won't have any issues because your spindle will be running straight from one end to the other. No issue. So there's no way for the bearing to twist. There's no way for the bearing to be misaligned. There's no way for the bearing to move or adjust itself inside the frame, and there's no necessity for the bearing to do that because you've got a true spindle, you've got a true shell, and you've got a true bottom bracket. Everything is going in the right direction at the same time. So your bearings last longer. The reason again why many people think that these last longer is because they are straight. When you start getting into the realms of these things, especially these ones which are made out of plastic, you start to hit other issues. Number one, the carbon frames that they're pressed into, that these bottom brackets are pressed into, are molded. The difference between a titanium frame or an aluminium frame or a steel frame is that they're cut. They're metal tubes, the bottom brackets are made out of metal, and as you can see from this one, it's a pretty beefy piece of metal. This must be, what, like, I don't know, 3 or 4 mils thick at least. Let me get a caliper on it and show you. So yeah, it's nearly 4 mil thick. It's 3 mil thick, but that's pretty thick. You're not going to bend that. That's not going to warp or twist under load because it's so thick. Because it's so stiff, there's really nothing that can go wrong with a solid titanium tube. Same goes for the aluminium one over there. Although aluminium's not as strong as titanium, it's still very thick. It's not going to twist under load. It's not going to warp or come out and be misaligned in any way. But when you make a carbon frame, and the frame has a carbon bottom bracket shell, and that bottom bracket shell is a press fit bottom bracket shell, that shell has been molded. It's not a solid tube that was then cut with a machine to be a perfect diameter. Molded things have less accuracy. For example, like these plastic cups here are going to be less precision, less accurate than these metal ones here. These are going to be almost perfect. These probably have some level of discrepancy in them because they're injection molded. The same, as I say, goes for the carbon frame. So it's molded. The main issue is that it's molded. Once it comes out of the mold, it has time to settle, it has time to twist, it has time to come out of alignment. If the curing process where they heat the frames to bake them basically into position and set the resins and set the glues, if that doesn't go well or there's any discrepancy in the mold that they're using, again, like I say, you'll get an uneven bottom bracket. And when you try and press something that even is precision, like these metal cups here are very precision, if you try and press this into an uneven bottom bracket, you're going to have problems. Because number one, if you imagine these two cups right now are straight, right? Imagine if there was a slight step or something, or a slight discrepancy in your BB shell. And I'm going to demonstrate ridiculously now. And one shell was slightly droopy, like that. One side of the shell was droopy. Or one side of the shell was slightly higher. Or one side of the shell was slightly twisted. That's how your bearing is going to look inside your bike. It's not going to be straight through. It's going to be twisted or misaligned, or, you know, just warped in some way. And then when you try and pass your spindle through that, the spindle is going to force those bearings to try and straighten up, which is going to put uneven pressure on those bearings, and those bearings are going to complain about it. And they're also going to wear out faster, because the uneven pressure on those bearings is going to cause them to wear out in an unusual way. You're going to create extra drag. Your frame, your drivetrain is going to be less efficient. Your spindle is going to be less efficient. You're going to do uneven damage to your spindle. And as I say, your bearing will start to complain. It will start to creak and squeak as it moves within the frame. Because as that spindle rotates within the frame, it goes from maybe a low point to a high point, and it's constantly shifting the bearings within the frame, trying to get the right alignment, and it just never can. So that's the first issue. Now, the second thing that they tried to do, I mean, the manufacturers know this already, and the main reason why they continue to make these carbon bikes with these molded shells is they don't care. The reason they don't care is most people out there don't understand anything to do with materials or engineering, and so the manufacturers know they can get away with it. They also know people are stupid enough that they want carbon fiber frames no matter what the cost, whether that cost be financial or convenience. Everybody has to have the carbon frame. So the manufacturers know that everybody is falling over themselves to buy these cheaply mass-produced molded carbon frames at exorbitant prices, and that they will just put up with the bad bearing quality or the bad bearing fit on their frames, or they just won't notice. And in those really extreme situations where they do notice, perhaps the manufacturer can just give them another frame, or they send their frame to someone like Hanbini, who will then make a bespoke bearing that is, you know, basically negating the misalignment within that frame by basically engineering a bearing from scratch and a bearing cup from scratch, as I say, that will negate that problem. And that's a really big problem in itself, because if you've got a 100% bespoke bearing that only fits to your frame, how are you going to do maintenance on that bearing? How are you going to replace that bearing? It means you have to go back to the same person every single time. Bearings are only good for maybe a few years at best, and if you've got a misaligned one, it's not going to be good for maybe a few months. So, and then when you come to clean those bearings, or you come to maintain those bearings, you again have risk factors. And how do you remove those bearings and press them back into those cups? Can it be easily done? I don't know, because obviously these specialist bearings which are made to repair the problems within these carbon frames, they are specialist, and so by their nature they are unique, and that might in itself prove to be a problem when it comes to maintenance. So that's the first reason is they, as I say, they just don't care. And the second thing is it's about the material properties. Carbon fiber is basically like this stuff, okay? This is just cloth, okay? This is just cloth. Cloth is made out of multiple fibers woven together. Carbon fiber is made out of multiple fibers woven together. And when you see carbon sheets in the factory, it's like this. It's flexible, it's movable, it doesn't have any rigidity. What makes it rigid is by injecting it with aerospace quality glue. Basically, you're gluing material together to make shapes. And so the natural state of that material is fluid. The natural state of that material is flexible. Whereas if you have something like this piece of metal, whether it be steel, aluminium or titanium, the natural state of this is rock solid. And if you take a huge lump of titanium and you mill it out to a particular size, it will maintain that strength and it will maintain that shape. So the issues that you're having with your bottom brackets is because of the bikes that you choose to buy. I am not saying that some manufacturers who manufacture threaded bottom brackets don't occasionally get it wrong. And I'm not saying that some manufacturers that manufacture press fit metal bottom brackets sometimes don't get it wrong. But they really have to get it wrong badly, okay? Whereas with the amount of carbon frames out there on the market, I would hazard a guess that at least 90% of them out there are misaligned. Maybe even more, maybe even close to 100% have some kind of misalignment or variation in them. And as I say, these kind of bottom brackets, the ones that thread together, these were designed to try and prevent the squeaking and the creaking that many of those bottom brackets get when the cups are constantly moving around inside the frame. These are designed to forcefully push their way into the frame to lock down tight so that you have a direct route for your spindle that cannot be affected by the external forces of the frame bending and twisting. And carbon frames are like that. They do bend and they do twist. Now, they tried to solve this problem by doing things like putting aluminium inserts into carbon frames. Those aluminium inserts were basically driven into the press fit carbon frames and then they were glued into place. And the idea behind it was that when you try to press your press fit bottom bracket into those frames, well, now you've got a metal tube, and we all know metal tubes are better, they're more precision. Those aluminium tubes could be cut precisely. They were heavier, but it was worth the sacrifice, right, to solve the problem with these carbon frames. Now, the idea was a sound idea, but it fell down in one major respect, which was that aluminium itself is very soft, especially if it's a thin tube. And these tubes that they were pushing into the frames, these aluminium shims, if you like, tubes, were very, very soft because aluminium is soft, and they were very, very thin. So that if there was any discrepancy in the carbon frame prior to you fitting the tube itself would get squashed or crushed, and then you're back to square one. You've still got a misaligned or, uneven bottom bracket shell to press your bearing into. There are other factors or other issues with those. Number one is galvanic corrosion. When you put aluminium next to carbon fiber, you get a reaction between the two materials. They start to eat each other. The carbon eats the aluminium away with corrosion. And eventually the aluminium bonded cup comes loose from the frame. So this is one of those particular specialized bikes I was talking about. It's a specialized tarmac in carbon fiber that a customer brought in. And as you can see, the carbon fiber has completely come unbonded from the aluminium sleeve. And as a result, the bottom bracket is now loose in the frame, and you can also see all the paint and everything cracking away from the frame. This is a particularly bad one, I must admit, but this does happen. And this wasn't an old frame, about 2 years old. And then the owner switched to this one, which is a Chinese brand bike called Gusto. Gusto for the Italian word for flavor, but there's nothing Italian about this bike. And it's also the same system, as you can see from this picture, which is a bonded in aluminium sleeve into a carbon fiber shell. You can also see this one's been very badly made. You can see the gaps around the sleeve where the glue is missing from the bike. You can also see that it's quite uneven. So you can also see how easily water is going to be able to get between the aluminium sleeve and the carbon fiber frame through all the holes that have been put in for the internal cable routing. Now, the manufacturers, as I say, really don't care about that, not even with the high-end brands like Specialized. It's something that they sort of know is probably going to happen, but they just put up with it. The other interesting factor is that if you notice the thickness, the total thickness of the aluminium sleeve, the glue, and the carbon fiber around the bottom bracket shell is no thicker than the titanium bottom bracket on the Lightspeed frame, which is obviously a lot stronger. And the other issue with them is, which you also get with the Specialized Allis frames, and as I say, this BB solves a lot of the problems that you get with the Allis bikes. Now, the Allis bikes are metal, so you're thinking, oh, well, you just said metal is better than carbon, right? Well, the problem with the Allis frames is they use these, BB30. Basically, inside the frame, there is a set of these C-clips. You push these into a groove within the frame, and then these bearings get pressed into the aluminium frame on top, and that C-clip stops the bearing from going too far into the frame, and then you can put your spindle directly through the middle. But there's a major problem with that as well, which is that these are made of steel, and these are made of steel. And when you put these and these into that much softer aluminium frame, you scrape the aluminium. You wear the aluminium by pushing these bearings in. And it's very hard to push them in accurately. Even with a really good bearing press, you still occasionally get problems. And once you press them into the frame, as I say, they scrape their way in and they press their way in, and they create unevenness in that shell. And they creak because you've got two metal surfaces rubbing against each other. And because it's not threaded in, unlike the threaded bottom bracket over there, which is threaded in and it's secure, these can move around. So again, you get misalignment within the frame, and a lot of people complain, especially about the Cannondale bikes, that they creak like hell. And the reason is that you've pressed a steel bearing into an aluminium frame, you've pressed a stronger material into a softer material. And then as you remove these and press them in and remove them and press them in, each time you come to service the bike and replace the bearings, and especially in the Allis, which tends to retain a lot of water in its bottom bracket, these rust really quickly. The solution is something like this, which is completely sealed from the inside, but these rust like crazy in the Allis frames, and so you're constantly having to replace them. And when you replace them, as I say, you do more damage, and then eventually you get an uneven bottom bracket shell. So this is looking inside a Specialized Allis frame, which is of course an aluminium frame. You can see all the dirt build up. The problem with these frames is that water rushes in when you're washing or riding in the rain. Moisture builds up within the shell of the bottom bracket because it's made in two parts, and you have like a trough in the bottom of the shell that you can just see through those holes. And that trough is not in any way vented. There's no way for the water to escape other than tipping the bike backwards, and many people don't think to do that. So that water just sits in there, and eventually the water becomes so high it comes up through those holes and starts to attack the steel bearings from the inside. And this dirt and rust that you can see in this picture is a result of that damage to those steel bearings. Unfortunately, I'd already knocked out the steel bearings at this point, but I can tell you now they were very, very badly rusted. And you can just barely make out the gap in the shell where the C-clip is going to go into the frame. In this picture, once the shell has been cleaned by myself, you can now see where the C-clip has been placed in. The other issue with the C-clip is it's got a little bit of movement in it. It can actually move backwards and forwards. It doesn't fit perfectly into that gap because it's slightly narrower than the gap itself that it slots into. So you have to be careful when pressing in the bearings to make sure that they are buttered up against that C-clip properly. Otherwise, again, they can wander around inside the frame. It's not the best system, really. Also, putting those C-clips in, you can scratch the aluminium, and you can also scratch the aluminium when you press in the new bearings as well. Again, that C-clip offers very little protection against the elements that are swirling around inside that frame, salty water, dirt and sweat that builds up inside the bottom bracket shell. Then moving on to the next picture, we have the finally installed bottom bracket. This is the BB30 that's been pressed in against those C-clips, and it had a helpful amount of grease, waterproof grease, put in there to try and prevent again the rusting, but you can't really do much because, as you can see, the waterproof grease is not really going to have much an effect if there's a lot of humidity and moisture inside that bottom bracket shell just sitting in there, which it often does. Moving on to the solution is this one, which is the one I showed you earlier on the cloth. This is the BB30 adapter to 24mm spindle, and this one is simply just screwed into the frame, threaded into the frame if you like. You remove the C-clips. This is a different Alès bike that a customer had, and you can also see the waterproof grease there preventing anything from getting in and around the bearing, and because the bearing itself is sealed, it doesn't matter if water builds up inside the frame. And there it is, fully installed. These really do solve the problem, so I do recommend, if you have an Alès, to get one of these style bottom brackets, because you're going to notice a lot less problems and they're going to run a lot smoother, and because they're screwed in tight, they're more true as well. You don't get that problem with the aluminium threaded because the threaded cups don't do damage to the shell every time you rethread a new cup into the shell, and you don't get that problem with titanium because titanium is much tougher than the steel. So it's not a problem for titanium, and we're not pressing steel bearings directly into the PF30 frames. We're pressing in something much softer, like these plastic cups, for example. So it's not a problem. And actually the type of bottom bracket that we favor, that we tend to use in these frames in the shop, is something like this. So you've got the added advantage of the screw fit, you've got the precision of the metal cups, and you've got a much tougher and more aligned bottom bracket shell. So you get zero issues with these at all. So basically, what is the solution? I mean, if this is the issue is the material that's being used and the way the material is being used. And again, I hate to bring up Specialized again, but they are one of the worst culprits for it, because they do favor press fit BB30 or press fit PF30 or all this press fit stuff. And then, you know, their most recent solution is to thread aluminium cups or put an aluminium threaded shell into the carbon bottom bracket, which again is exactly the same problem as them inserting an aluminium shell into a carbon bottom bracket that they did before. There's no difference, only this time they're using threaded shells, threaded aluminium within the carbon frames. And the reason they're doing that is for marketing purposes, because now they can tell people, look, our carbon frames now come with a threaded shell, but it's useless because you can't thread directly into carbon fiber, so you have to put an aluminium insert in there. And the issues that they had with their aluminium inserts previously are not solved. You're still going to get galvanic corrosion. You're still going to get warping of that threaded channel. And it's still not going to be as stiff, because even if this threaded bottom bracket fits perfectly into that little thin aluminium shell and fits snugly and tightly in there, it's still going to start twist and moving around and separating itself from the carbon body of the frame. So it hasn't solved the problem. None of these things have solved the problem of basically using materials correctly. You would never make a hammer out of cheese. You would make a hammer out of steel, because steel is strong and heavy and resilient, and it makes a very, very good hammer. You wouldn't make something out of a material, and you wouldn't use a material inappropriately, and that is what the bike industry are doing right now. You can't mistreat material like that and expect it to work. There are fantastic applications for carbon fiber. Don't get me wrong, it's a wonder material. There are fantastic applications for it. But bottom bracket shells or bike frames is not one of them, in my opinion. You're much better off getting a Thai bike or an aluminium bike or a steel bike, because the negative side of metal bikes is vastly outweighed by the positive sides of not having to deal with this issue with regards to carbon fiber frames. And like I say, all those people who love carbon fiber and who are in carbon fiber engineering, all they ever do is make excuses. And then when you bring up things like galvanic corrosion, like issues with the discrepancies in molding of the frames, like the fact that when you drop a carbon bike, it can be damaged internally. You can get delamination but not know about it. Like the fact that if you crash a carbon bike, you really do need to send it for an ultrasound scan because you simply cannot tell if it's safe or not. They sound like the people that say, if only they would implement, carbon fiber technology properly, we wouldn't have any of these problems. But all we ever see is reoccurring problems. And how long have we been making carbon fiber frames for? Is it 10 years? Is it 20 years? Is it 30 years? How long have we been making carbon fiber frames? And how long have we been having bottom bracket issues? And have they solved the problem yet? No, they haven't. They keep trying. And if you look at what the manufacturers are doing, all they're doing is trying to make this into carbon fiber and this work for carbon fiber, and it doesn't work. But this and this work for metal frames. So to illustrate that point further, and to give a perfect example, we can see from Bastian Cycles in Australia, who are previously, they were engineers in the automotive industry, and they're proper engineers, unlike the ones that are in most of the cycling industry. They're using 3D printed titanium bottom brackets, and what they're doing is gluing those into a carbon fiber tube set, as you can see. So they're eliminating the issues that come along with having carbon fiber bottom brackets, and they're also lugging the frames like traditional steel frames used to be lugged. It's a great idea. Personally, I would just go for a full titanium frame because I don't see the benefits in the carbon fiber, but it's still a very good idea. Now, my personal opinion about 3D printed technology, especially with regards to titanium, is that it would be the future of bike frames if the industry currently wasn't making so much money out of mass-produced, cheaply made carbon fiber products. And I think the issue is that until there's a change and until there's pressure on the industry to improve, there's really no point in them developing this technology further, and you will only see it in these bespoke kind of companies. It's actually a way that titanium could become much more feasible, because the main issue with titanium right now is it's very hard to produce, and it's extremely time consuming, and it takes a great amount of skill and precision to weld, butt and shape titanium tubes. If you could get a computer just to 3D print it, really there would be nothing that titanium couldn't do better than carbon fiber, both in strength, power to weight or stiffness to weight ratio, aerodynamics, longevity, everything. But I guess the other factor is that if you had a titanium bike frame that was capable of lasting pretty much a lifetime, being modular, so being made out of modular modular titanium lugs and tubes that could be switched out and replaced if damaged, that was fully recyclable, that could be melted down and reproduced, could be printed in a matter of hours rather than made in a matter of days, and could be conceivably any shape and any design, it would literally revolutionize the cycling industry so much that it would probably almost cause the destruction of the cycling industry. Because of course, if you can print your own frames, or you can print frames so easily, and they lasted so long, there wouldn't be any need for you to go out and buy a brand new carbon fiber bike every year, which is currently what they're encouraging you to do, because you would have a never-ending bicycle, basically. It may even be possible, as I say, to upgrade the tube set as you went by just buying a few new tubes and then having those welded back into the frame. So yeah, 3D printed titanium, I think it would be the future. So, unfortunately, other than getting yourself a type of bottom bracket like this that threads together through the frame and creates a stiffer bottom bracket, there isn't really a solution if you have, unfortunately, bought a carbon fiber bike. You are going to have bottom bracket issues. You're going to have bottom brackets that wear out faster, you're going to have bottom brackets that creak, or you're going to have aluminium shells within your bottom brackets that corrode away because of galvanic corrosion, okay, and then eventually come separate from your frame. And hopefully the warranties of whatever manufacturer you gave your money to will cover that issue. But my advice on how to solve bottom bracket issues is don't buy a carbon frame. Buy a steel frame if you're looking for a long distance bike on a budget. If you're looking to race in crits or, you know, road race, go for a good quality aluminium frame like this Bowman Palisade. This is literally the best aluminium race bike on the market right now. It's super stiff. It's got a 10 out of 10 rating. It's really light. I did a demonstration video at my shop where I compared a Villiers carbon frame against that and a Villiers carbon frame against one of our titanium bikes. The Villiers carbon frame was more expensive than both the aluminium and the titanium bike frame, and the titanium was lighter and the aluminium frame was only 200 grams heavier. I mean, I'm not against carbon fiber for other purposes. I think like carbon fiber accessories on your bike, like a carbon fiber saddle or a carbon fiber handlebar or something like that, or even carbon fiber wheels, you know, they are great, they are fantastic, and you cannot get the aerodynamics to weight sort of ratios that you're getting with a carbon fiber wheel, the really high-end stuff. But yeah, when it comes to bike frames, they're not the best. Initially, it started out to be a little bit of an informative video, and then it became a bit of a rant because I do feel very passionately about this subject. I feel like so many people out there, including, you know, customers that I know, are being cheated and conned every day into buying this crappy, poorly made, cheaply made bikes that are just a headache when they come in the shop because they got numerous problems. And like, I've fitted spindles to bikes where I've had to use a mallet to get the spindle to go through because the bearings are so misaligned, you know, or I've had to put the spindle in the freezer to reduce its size to get it in because the bearings are so misaligned, and the bearings are misaligned because the carbon bottom bracket shells are crap. But anyway, that's enough of that. Thanks for watching, and as always, when you're out there on the road, stay safe. See ya. Thank you for watching, and don't forget to click subscribe and the notification bell for more videos on this subject. Thank you.